Hey guys, I am out of town today, so you will just watch this video instead of having like actual class, if that makes sense. So the first 5 minutes, what I'd like you to do is complete the do now. So you can hit pause until you're done with the do now. Then once you're done with the do now, then you can restart watching this. And then whenever there's a knowledge check, you just pause, take the knowledge check, and then you can unpause, okay? So this video will probably be only about 20 minutes long because I'm factoring in you pausing the video and then restarting it, okay? So you are doing the do now right now, and you're gonna pause, and then as soon as you're done, then you're going to hit play again, okay? All right, so I'm gonna kind of re-go over really briefly what we covered last week. And then you're gonna start off right off the bat taking a knowledge check. So the very first thing that we went over last week was perpendicular angles. The biggest thing to know here is that perpendicular angles create 90 degrees. On this next slide, we talked about how 90-degree angles, those can be denoted by a box, which in this case, your box is right here, and that means that it is a 90-degree angle. Okay. Obtuse angles are anything that is larger than 90, but smaller than 180. Acute angles are anything that is larger than 0, but smaller than 90. And a straight angle, this may have been a new term for you. A straight angle is exactly 180 degrees. Okay, characteristics of straight angles. The first thing is that there are two opposite rays. In this case, they're going this way. And the vertex of B is going to be in the middle. We also know that all straight angles are congruent. And we know that all of the points on a straight angle are going to be collinear, because a straight angle is a straight line, and collinear has the word line in it. So that just kind of makes sense. A reflex angle is anything that is larger than 180 degrees. So we talked about last class kind of like a circle, like this. And this part of the pie would be the reflex angle. And then this part of the pie would be the interior angle. And you could subtract the reflex from the interior to find, you could subtract the reflex from 360 to find the interior. So that is how you do that. And then here's just an overall picture of all of them. Things to remember before you take your knowledge check is that you have an acute angle, and it is smaller than 90. A right angle is exactly 90. An obtuse angle is larger than 90. A straight angle is exactly 180. And a reflex angle is larger than 180. So what you're going to do right now is you are going to pause this video and take the knowledge check. You have 1, 2, 3, 4, 5, 6, 7 questions. And then once you're done with that knowledge check, then you may unpause me and start again. Let me look up real fast what that knowledge check is called for you. 1 second. So you are taking knowledge check called types of angles. So types of angles knowledge check, it's questions 4 through 10. Types of angles knowledge check. And then pause me, and then once you are finished, we will restart, okay? So you're unpausing now because you are ready for me to go over this with you. I'm going to begin my screen share again. And what I'm going to do is I'm going to play this lady to go over it, and then I will add anything that needs to be added.
Right angles
Nope, this
and
is not right.
perpendicularity.
Sorry, guys. 1 second.
Definition
Oh my
10.
goodness.
When a straight line standing
Where is
on a
this even
straight
coming
line
from?
makes the adjacent angle.
There we go. Okay, sorry. Here we go. This is the one that's supposed to be playing. My bad.
This is an example of an acute angle because 45 degrees is less than 90 degrees but greater than 0 degrees. So the answer is A.
Okay, so it's so cute. It's little, it's a cute. I don't think there should be any questions on that one. Question number 5, let's go over this. So question 5, this is an example of a blank angle. Well, what do we think? When we look at this, we notice that this is 90 degrees. There also could have been a box drawn right here. So therefore, we automatically know that this is a right angle. All right, anybody have any questions on that? Nope. All right. Question 6, this is an example of a blank angle. So looking at this, I'll have her explain it just so you don't have to listen to my voice this whole video.
This is an example of an obtuse angle. The measurement of angle ABC is 135 degrees, which is greater than 90 degrees but less than 180 degrees, which means it is obtuse, B.
So an obtuse angle opens larger than 90. Question 7, this is an example of a
This is an example of a straight angle. An angle with a measurement of 180 degrees is a straight angle. So the answer is D.
Question number 8, this is an example of a, let me see. Oh, well, now she doesn't, there we go. Hang on.
This is an example of a reflex angle because it's an angle that is greater than 180 degrees. So the answer is D.
So it's like basically completing the other half of the circle there. Question number 9, this is an example of a, well, you have 270 on the outside, and that is larger than 180, therefore we know that this is also a reflexive angle. Okay, if you wanted to figure out what was left in here, if you wanted to figure this out, you could take 360 minus 270, and that would give you what this angle on the inside is. Oh my goodness. This erased, sorry. Erase the other ones. Okay, good. So next question, this is an example of a what kind of angle? Well, let's have her tell you. I'll do every other one for you.
This is an example of a reflex angle. 315 degrees is greater than 180 degrees, so this is a reflex angle. This angle here is an acute angle, but we're looking at 315 degree angle instead, so the answer is D.
All right, so if you have any questions about this, you can email me or you can ask me in class on Thursday. We're now gonna start with naming angles. So I'm gonna play the video for you and then I'm gonna walk back through and go back through everything.
Naming angles. An angle has 3 parts. It has 2 sides and 1 vertex. In this example, the sides are the ray BA and the ray BC, and the vertex is the point B. Interior of angles. Any angle with a measure of between 0 degrees and 180 degrees has an interior and exterior as shown below. The interior is here, and the exterior is out here. An angle can be named in different ways. It can be named by its vertex B, as shown in this figure here. It can be named by a point on one side, its vertex, and a point on the other side. So in this example, ABC or CBA, the direction does not matter. It could also be named by a number or a symbol placed inside the angle, as shown with the Greek letter theta here. The angle shown can be called angle ABC, angle CBA, or angle B. When there is no chance of confusion, the angle may also be identified by its vertex alone. The measure of angle ABC is 32 degrees, and that's written like lowercase m, angle ABC equals 32 degrees. Using the vertex to name an angle doesn't work in some cases. Why would it be unclear to use the vertex to name the angle in the image below? Well, we can't use B as the name of any angle because there are several different angles that share B as the vertex. How many angles with measure less than 180 degrees do you count in the figure? Well, there's this angle, there's this angle, and there's this angle. What other ways could you name angle ABC, angle ABD, and angle DBC in the figure below? All right, so angle ABC is this angle here, so we could also name it CBA because the direction does not matter, so it's ABC or CBA. ABD is this angle here, ABD, so we could also name it DBA. And finally, the larger angle here is angle DBC, so we could also name it CBD. How could you name those three angles using the letters placed inside the angles? Well, the purple angle is also theta, the green angle is alpha, and the blue angle would be theta plus alpha. Intersecting lines form angles. When an angle is formed by either two rays or segments with a shared vertex, one included angle is formed, shown as theta in the below diagram to the left. When two lines intersect, four angles are formed. These angles are numbered in the diagram below to the right, 1, 2, 3, and 4. In the figure below, two lines intersect. The numbers 1, 2, 3, and 4 have no special significance, but are simply used to name the four angles. It's not unusual to label angles in this way. When rays or segments intersect but do not share a common endpoint, they also create four angles.
Okay, so kind of backtracking so we can spend a little more time on each of these slides. We are starting here with naming angles. An angle has three parts. It has the sides and the vertex, which we went over last class, but I can go ahead and highlight this again for you. So if we were talking about a side, we have this side, which in this case would be ray BA. And then we have this side, which would be BC, ray BC. And we know that the corner, or where they meet, is the vertex, which in this case happens to be B. So if we wanted to name this angle, we could call this angle ABC. Oops, sorry. Or we could call it CBA. Oh my gosh, this thing keeps trying to play. We know that the vertex is B because in both cases it is in the very middle. Okay. So we have interior angles, which in this case is marked with theta. So this is an interior angle. An interior angle has a measure between 0 and 180. An angle has an interior and an angle also has the exterior. As we spoke about before, this exterior part is called the reflex angle. So basically you can create a circle, and some of your circle is the interior, which in this case is labeled as theta, and the exterior, which is the reflex in green. Now we're going to talk about how we name angles. An angle can be named in different ways. It can be named by a point on one side of its vertex and a point on the other side. So in this case, what it's talking about is, we could call this ABC or CBA. So we could call this angle starting at A to B to C, ABC. Or you could go backwards and say CBA. And in a very, very small instance, for this case, if there's only one angle in the picture, you could name it by the vertex. So there's only one angle on this whole page, so we could also call this angle B. But that only works if there's one angle on this page, okay? So naming angles, just like we just did, we could call this angle ABC. And when we call it ABC, we're starting at A, going to B and C. Or we could call this CBA, so C to B to A. Or since there's only one angle in this entire picture, you could just call it by its vertex, which is B. What we want to make sure is that we're putting this symbol right here in front for all of these: angle, angle, and angle, okay? That way there's no chance of confusion, okay? If we want to talk about the measure of this angle, we could put in front of all of these, backtracking again, we could say that this is the measure of angle CBA equals 32 degrees. You could say the measure of angle B equals 32 degrees. Or you could say the measure of angle ABC equals 32 degrees. And no matter how you write that, someone is going to know exactly that you're talking about this angle. So this is an example where it would not be good to name an angle just by its vertex, because there's more than one angle in this picture, okay? So using the vertex to name an angle does not work in some cases. Why would it be unclear to use the vertex to name the angle in the image below? How many angles with measure less than 180 do you count in the picture? Well, this is why you can't use the vertex. So we have this angle right here, so that's 1. And then you have this angle right here, so that's 2. And then you have this angle right here, so that would be 3 angles, which is why you cannot just call this angle B, because how would it know which of these 3 angles you were talking about? So when we talk about how we want to name this, we can talk about each one of these independently. So you can name it ABC, which would be this one in green, ABC. Or you could call it ABD, so A to B to D, which is the one I just did in orange. Or you could do it in purple, DBC, so DBC. So that's exactly why you could not use B just to name this angle, because there's too many different angles, okay? So how could you name those 3 angles using the letters placed inside the angle? Well, you could call, like, this ABC, you could also mix this up, and you could call it CBA, like the same thing. So anytime you see something like this, you could name it the backwards way. So ABC could be CBA. The big thing is that B just has to be in the middle because it's the vertex. So now we're going to talk about intersecting lines form angles. From an angle, when an angle is formed by either 2 rays or segments with a shared vertex, one included angle is formed, shown as theta in the diagram to the left. When 2 lines intersect, 4 angles are formed. These angles are numbered in the diagram below. So this one is talking about how 2 rays or segments are doing it, and then this one's talking about how 2 lines are creating it. So this is very different, because on the right-hand side, we have 4 different angles, which are outlined, but we can do it in different colors. So you have your purple one here, which is 1. And then you have your orange one here, which is 2. And you have your green one, which they called 4. And we can do this one in blue, which they called 3. So there are 4 different angles in this picture to the right, whereas in this picture over here to the left, you only have the 1 angle right here, okay? So intersecting lines form angles. In the figure below, 2 lines intersect, and the numbers 1, 2, 3, and 4 have no special significance, but are simply used to name the 4 angles. It's not unusual to label angles in this way. When rays or segments intersect but do not share a common endpoint, they also create 4 angles. So essentially what they're talking about is, like, this is not a measure of the angle. We know that this is not the measure of an angle because this is an obtuse angle, so there's no way it could have a degree of 2. It would also have to have a degree sign after the 2. So this is just like a way of naming this angle. So if they did not put numbers in here, like we could have called this one the heart, and this one the star, and this one the square, and this one the circle. But they use numbers just to make it easier, but it's the same concept. Essentially, they put something in that angle, that way we'd know what they were talking about. So you now have a knowledge check, and you'll take this the rest of class, and then also complete the exit ticket, and we will pick up here next class. So you have about 10 minutes to do this knowledge check, and then you have 5 minutes to do your exit ticket. And that is your class today. And then we will pick up on Thursday talking about congruent angles. All right. You guys have a great week. You can do this, watch this video whenever, get this knowledge check done. Just make sure it's done by Thursday. All right. You guys have a great day. See ya.